So question 1 tells us that every day in the Nielsen, 4,950 cups of coffee are sold at a price of 18 Rand each. The price elasticity of demand for coffee is 1.3. If the price were to be increased to 22 Rand per cup, what would total revenue per day be? So this is quite a tough elasticity question. And the reason why I say that is because what we get given is an elasticity value, and we get, 1.3, and we get given a quantity and price combination. So this is Q1, this is price 1. And then we get given a second price, but we do not get given the corresponding quantity with this price. But we can find that quantity using our elasticity, because we're going to need this quantity in order to calculate our total revenue. So the total revenue that we're now going to be interested in is going to be price 2 times Q2. So we know that this is 22, but this quantity 2 is what we are missing. So our elasticity value is 1.3. How we would have calculated that elasticity value is it would have been computed as minus the percentage change in quantity demanded over the percentage change in price, which we can also write as minus the change in quantity over the original quantity divided by the change in price over the original price. So this would be QD1 and this would be price 1. And we could also represent that as minus change in Q over the change in price times price 1 over QD1. What I can do now is I can sub in the values that I do have into this equation. So what I have is 1.3 is equal to minus, and then I'm going to have the change in quantity, which is going to be quantity 2 minus quantity 1. So it's the new quantity less the old quantity, divided by the change in price, which is the new price less the original, times the original price over the original quantity. And now I can sub in my price 1, my quantity 1, and my price 2. So 1.3 is equal to minus, so Q2 is my unknown, Q1 is 4,950, price 2, which is 22, minus price 1, which is 18, gives me 4. And then price 1 is 18, and quantity 1 is 4,950. So then I'm going to have 1.3 equals minus, and then I'm going to have, so 18 divided by 4,950, I'm actually going to take that to the other side. So I'm going to say that this is 4,950 over 18. So I'm just taking this times and putting it on the other side, and then I'm going to inverse it. And then I have Q2 over 4 minus 4,950 over 4. 357.5. And this is going to be minus Q2 over 4 plus 4,950 over 4. So the reason why it becomes plus is because the minus and the minus. And so what I then end up with is 357.5 equals minus Q2 over 4 plus is 1237.5. Then I'm going to take this quantity to this side, and it becomes positive then. And then if I take this to that side, I'm going to subtract it from 1237.5. So then I get 880. And that means that the quantity is going to be 3520. So based on my elasticity value, the quantity that corresponds with the price of 22 is 3,520, which means my total revenue is going to be 3,520 times 22, and that gives me 77,440. And that corresponds to B. So the answer to this question is B. There is actually one other way that I could have solved this. And I'm just going to show you quickly how that would look. So starting from this point here, right? So 1.3, which is the elasticity, would be minus the change in QD over the change in price. And my price one is 18, and my quantity one is 4,950. And so I could have said 1.3 is equal to 18 divided by 4,950. So this is minus change in quantity over change in price times 0.003636 recurring. And if I divide it through by that, I would get 1.3 divided by 0.003636 recurring. And that would give me that 357.5, which is minus the change in quantity over the change in price. And from the question, I know that the change in price is 4 because it's going from 18 to 22. So I could say that 357.5 equals minus change in QD over 4. And if I then multiply both sides by 4, I get 1430 is minus the change in QD. This tells me that the change in my quantity when price is reduced by 4 is going to be 1430. And so the quantity, if the change in quantity is minus 1430, then my new quantity must be my old quantity, which is 4950 minus 1430, and that gives me 3520. So I could have also come out at that answer in this way. Okay. So the answer to this question is 77,440. This is quite a different approach to the typical way of asking the elasticity question, because typically with elasticity, we would ask you to calculate the elasticity and then tell us what would happen to total revenue given a certain price change. But what we've given you here is the elasticity, 2 prices and 1 quantity, and you're having to solve for the quantity. Question 2 then says the price of insulin, a medicine used by diabetics, increases, but the quantity of insulin purchased by diabetics remains the same. This is an example of price elastic demand, which would mean elasticity is greater than 1. Perfectly price inelastic demand, which means it is exactly 0. Unitary price elasticity of demand, which means it's 1, or perfectly price elastic demand, which means it is some really large number. So based on this information, what we're saying is that if price increases, quantity doesn't change. So the numerator is the percentage change in quantity demanded. If the amount being purchased doesn't change, what would the percentage change in quantity demand be? It would be 0. And so if we take 0 divided by some price change, we get 0. And so the answer is B. It is perfectly price inelastic demand. How perfectly price inelastic demand looks is it is a vertical demand curve. And so if the price of this product had to increase, there would be no change in the quantity purchased. This differs from perfectly elastic demand, which is how a perfectly competitive firm's demand curve looks, because what this tells us is that at this price 1, quantity 1 or quantity 2 could be purchased. So even if price remains the same, any quantity can be sold at that price. Here, it tells us that for this quantity, any price could be charged and this quantity would remain the same. How I remember these is this is an I, so inelastic. This is an E, and so elastic. So perfectly inelastic is a straight vertical demand curve. Perfectly elastic is a straight horizontal demand curve. So there's the E, and here's the I. If I wanted to draw a demand curve that is relatively inelastic, then using this extreme as our reminder, a relatively inelastic demand will be quite steep, whereas a relatively elastic demand will be flat. So question 3 tells us that there is a bookstore that wants to increase its total revenue. One strategy is to offer a 10% discount on every item it sells. The bookseller sells 2 products, books and coffee. The table below shows how consumers of the 2 products respond to the discounts. So what we have here is that the percentage change in price is 10%. And now we need to calculate the elasticity of demand for books and the elasticity of demand for coffee. And we're going to use the formula percentage change in quantity over the percentage change in price. The percentage change in quantity over the percentage change in price. We get given the percentage change in price, which is 10%. And so what we need is the percentage change in quantities for each of these 2 products. So what this table tells us is that before the price discounts, so at the original price, 1.55 million books would be sold. After the price discount, 1.65 million books would be sold. In other words, what we can do is calculate the percentage change in quantity when this price discount applies. So the percentage change in quantity here would be 1.65 minus 1.55 divided by 1.55. So the change in the quantity demanded of books is going to be 0.1 million, and divided by 1.55 million, which is the original, we would get 6.452%. And the price decrease, it's a minus 10% because the price is being decreased. And so the elasticity for books is going to be 0.645. So the quantity is going up by 0.1 million. So the percentage change in books is going to be 0.1 million divided by 1.55 million, which is the original quantity. If I take that and I divide it by the minus 10% change, because the price of books is changing by minus 10%, it's a discount, so the price is going down. And so that gives us 0.645. So I'm going to put a minus in front of there as well. So here, as a result of the price discounts, the change, so the percentage change in quantity that we're going to calculate is going to be the change, which is 1.7 minus 1.5 divided by 1.5. So the change is 0.2 million. So 0.2 million additional coffees are being bought. So the percentage change in that, 0.2 divided by 1.5, gives me 13.33 recurring percent. And so my elasticity for coffee is going to be 1.333. So what I find is that the elasticity of books is less than 1, but the elasticity of coffee is greater than 1. So this has inelastic demand. This has elastic demand. So now the question is, would you advise that the bookstore offers a discount on both products? Explain by referring to your answers in B. So should the bookstore reduce both prices by 10%, or should it decrease neither by 10%, or should it decrease only one of them by 10%? If no, if your elasticity is greater than 1, so if you have a price elastic good, you would increase your total revenue if price goes down. So if you have a price elastic good, total revenue would go up if you lower your price. If you have an inelastic good, then your total revenue would increase if you increase your price. So the reason why increasing the price of an inelastic good would raise total revenue is because our consumers are not very responsive to price changes. And so by increasing our price, we're not going to reduce quantity by as much, and it means we could make more total revenue overall. But if we have elastic demand, then consumers are really responsive to price changes. And so if I lower the price, I'm going to have a larger relative increase in quantity, and that means I could get greater sales revenue overall. So no, I would advise that they only offer the discount on coffee because it is price elastic. Lowering the price of goods where E is greater than 1 would lead to greater total revenue. Increasing the price of books, actually, let me put it the other way, decreasing the price of books, so applying the discount to books, would reduce total revenue. Okay, so question 4 gives us the following graph, and it shows the demand and supply curves of some good. The government then introduces a per unit tax of 22 Rand on suppliers. The price paid by consumers following the introduction of this tax would be what? Okay. So this is the supply curve without the tax. What I know is that if it's a per unit tax of 22 Rand, it means that the supply plus tax curve is going to be the supply curve, but vertically shifted up by the amount of the tax. So I'm just going to roughly estimate where that would be. So the supply plus tax curve is going to be parallel to the supply curve, but the intercept is going to be 22 higher than 16. So this is going to be 38. So what we're trying to solve for is that price over there. So what we want to know is, what is the price that consumers are going to have to pay following this tax? Now, looking at the answers, is it possible that this price is 60 Rand? Is it possible for that price to be 74 Rand? No. So we're having to figure out, is this price 56 or 58? Because those two numbers fall in between 52 and 60, which is where this new price should end up. Okay. So how am I going to solve this? If I wanted to find this price over here, I would need to know what the function of the demand curve is and the function of this supply plus tax curve. Now, how could I find the equation of the demand curve using the information given to me in this question? So I have 1 point on my demand curve, which is a price of 52 and a quantity of 400. So this is 1 point on my demand curve. And then I have a second point on my demand curve, which is the intercept, 60, 0. So those are 2 points on my demand curve. So if I had to write out my demand curve, it would have an intercept, and then it would have a negative slope times quantity. What is the intercept of my demand curve? Awesome, 60. What is the slope of my demand curve using these two pieces of information? So what I see from this information is that when price changes by 8, quantity changes by 400. And the slope of this demand curve tells me, how does price change when quantity changes? So when quantity changes by 400, price changes by 8. And so the slope of this demand curve is going to be, yes, 1/50. How would I get the function of my supply plus tax curve? So it's also going to have an intercept and some positive slope times Q. What is the intercept of my supply plus tax curve using everything we've drawn in this picture? The intercept is 38. Okay, now how would I find the slope of my supply plus tax curve? So recognize that these two curves are parallel to each other. The supply curve and the supply plus tax curve are parallel. So if I know the slope of my supply curve, I also then know the slope of my supply plus tax curve. I also have 2 points on my supply curve. I have the point 452, because this is the equilibrium, so it applies to both the supply and the demand curve. And I have the intercept, which is 0, 16. So using this information, what we see is that when the price changes by 52 minus 16 is 36. So when the price changes by 36, the quantity changes by 400. And so what is the slope of the supply curve, which would also be the slope of the supply plus tax curve, if a change in price of 36 gives us a change in quantity of 400? 9/100. Perfect. Okay, 36 divided by 400 would be 9/100. So now I have my two functions. And so I can solve for this price by setting these two functions equal to each other. 60 minus 1 over 50 Q is equal to 38 plus 9 over 100 Q. I take like with like, so I take 38 to this side and I get 22 is equal to 9 over 100, then plus 2 over 100 would be 11 over 100 Q. And that means that my quantity is going to be 200. So this quantity is 200. And if the quantity is 200, what would the price be? I can sub this 200 into this demand curve, and I get price equals 60 minus 1 over 50 times 200, which is 4. So it's going to be 56. So how do I identify the per unit tax? Remember, these two functions are parallel. And so the difference between them is the tax. So the vertical distance between these two functions is the per unit tax. And so if we look at the intercepts, the difference in the intercepts would reveal the tax to us. So the tax is 42 minus 15, which is 27 Rand. Awesome. So if you don't get given the tax in the question, you can identify it by looking at the intercepts. Question B then says, what is the price paid by buyers of pizza following the imposition of the tax? So what is this price as a result of this tax in the markets? Remember, the vertical distance between these two curves is the tax of 27. At this point here, we have 28. In other words, if we moved vertically up from this point to that point there, that difference should also be 27. And so this number over here would be the 28 plus the 27, which is 55. So buyers pay 55 Rand. What price do sellers receive? So this is 55. What is the price that sellers are receiving after the tax? So buyers pay 55 Rand to the sellers. The sellers then hand over 27 Rand in tax to government. And so how much do they get to keep after they've paid the 27 Rand? 28 Rand. Question C then asks, calculate the size of the deadweight loss due to the tax. So if we look at this picture, we see that 26,000 ends up being the amount bought and sold, so the amount of pizza bought and sold. What is the efficient amount of pizza bought and sold? So what would be the socially optimal or efficient amount of pizza bought and sold? Okay, so this is the efficient quantity of pizza. And the reason we can say this is the efficient quantity is because this supply curve gives us the willingness to accept of sellers. This demand curve gives us the willingness to pay of buyers. And so that equilibrium there is where the willingness to pay of the marginal buyer equals the willingness to accept of the marginal seller. And this is what defines Pareto efficiency. Remember, tax is not a cost of production, or at least it's not a direct cost of production. So it doesn't form part of sellers' willingness to accept. At this quantity of 26,000, the willingness to pay of buyers is the 55 Rand, and the willingness to accept of the sellers is 28 Rand, which means that at 26,000, the willingness to pay exceeds the willingness to accept. And so there are unexploited gains from further trade that would occur if we could still trade pizza beyond 26,000 up to the efficient quantity of 44,000. And so this yellow triangle here represents the deadweight loss due to the tax. So how am I going to calculate the size of this deadweight loss? I'm going to use the area of a triangle. So that yellow area there is a triangle. And so I'm going to say the deadweight loss is equal to half times base times height. The base of this triangle is this distance here, 55 minus 28. So the base is 55 minus 28, and the height is this distance here, 26,000 to 44,000. So this is the height. And if I do that calculation, I get 243,000. Yes, great. And it's in rand terms. So we're measuring the monetary value lost due to the inefficiency. Please give a definition of deadweight loss. So deadweight loss is a social cost that measures the unexploited gains from trade. So what I mean by that is, if we look at 26,000 pizzas, the maximum willingness to pay of the last person who bought a pizza exceeds the minimum price that the seller was willing to accept. This indicates that there is a net surplus in this transaction. So when this last pizza was sold, the buyer paid more than what the seller was willing to accept. And so there is a surplus. Even if we had to sell one more pizza, so 26,001 pizzas, that willingness to pay would still exceed the minimum price willing to accept. And so there would be a positive surplus as well on that pizza. In fact, every single pizza between 26,000 up to 44,000 has a positive gain. There is a surplus that measures the difference between what someone was willing to pay for the pizza and what the minimum price that someone was willing to accept for the pizza. And so when we restrict quantity to 26,000, we are missing out on these joint surpluses, on these gains from trade. And that is why it is a social cost. It means that the buyers and sellers in this market are missing out on these surpluses. Are you happy with that definition, Ms. Longmore? Great. Okay, then D. Oh, D is good because now this addresses Ms. van der Merwe's question. D says, who bears the larger tax burden, buyers or sellers, and why? No calculations are required. So I'm actually going to do some calculations just because in a test, maybe you would be required to calculate this. So if we look at the price that buyers pay and the price that sellers receive, there is a difference. And the difference between what buyers pay and what sellers receive is this 27 rand tax. So we say that the per unit tax drives a wedge between these two prices. How do we then go about identifying the amounts of this 27 rand tax that the buyer ended up having to incur and the amounts of this 27 rand tax that the seller had to end up incurring? What we need to know to identify the burden is what this original equilibrium price was. This is only if I want to calculate it, right? So if I wanted to figure out what the tax burden is, I would need to know what this equilibrium price is here. Trying to see if I actually have enough information here to calculate it. I actually don't have enough information. Okay, so that's probably why part D said no calculations required. So I'm just going to do it theoretically. So what we say is that the tax burden of the buyer is the difference between the price they now pay with the tax and the price they used to pay without the tax. So the tax burden of the buyer is this vertical distance here. They used to pay this price and now they pay this price. In other words, of this full tax amount per unit, the buyer is having to pay this portion of the per unit. The seller, on the other hand, used to receive this price, but now they only receive 28. And so this vertical distance here is the burden of the per unit tax on the seller. So we find the burden on buyers using the price with the tax less the price with no tax. And we find the burden on sellers as the price with no tax minus the price that they receive with this tax. So the price that buyers pay with the tax and the price that sellers receive with the tax. So that's how we would calculate it. Looking at this picture here, who bears the larger tax burden, buyers or sellers? The buyers. Okay, so buyers bear the larger tax burden. So that's the first part of the question, 1 mark. The second mark comes from arguing why. So looking at this picture, why do buyers pay a larger portion of the per unit tax? The demand curve is steeper than the supply curve. And so demand is going to be less elastic than supply. Okay, so because the demand curve is steeper than the supply curve, demand is relatively less elastic or more inelastic than supply. Okay, so demand is less elastic than supply.